Most Science Olympiad EVs go straight and hope for the best. Mine does not. This is my Science Olympiad electric vehicle, or EV. The goal is to make this drive a specific distance at a specific time. And to win, you have to match those two parameters as closely to the target one as possible. Sounds simple, right? Well, let's go take a look at this.
So on the track for the event, there's my EV at the beginning, and there's also a finish tape at the end. So this is where I want my EV to end up exactly, to maximize my score. Now between this tape and my EV, there's a distance called a target distance. And for example purposes, I'm just going to say it's 8 meters. In addition to the target distance, there's also a target time, which I'm going to say is 18 seconds, for example. And I want to maximize my accuracy on both these two numbers in order to ensure I have the highest score possible. Now, what makes this interesting is that while normally on this straight run, it's pretty simple. You go across, stop, earn points. There's also an opportunity to earn bonus points if you have two cans placed out to the side, bonus cans. And by going through these cans and finishing at the end, you can maximize your score and earn a higher score than those people that just go straight. Now, to achieve this, most teams set up their EV like this, with a fixed steering, usually set by a caliper or some other form of measuring device that can ensure accuracy and repeatability each time. And by setting up like this, they just run the motor along this arc and it stops. And this is good, but only when you're in your testing environment, because you never know what type of floor you're going to get and other sort of environmental factors during a run at the actual event. So they've tested it, all the parameters, and they set it to the environment they tested back at their school. But when they go to the actual place to test it, it can very easily veer off and end up in the wrong place. And this is my approach. I have two waypoints, 1 and 2. And what I do is I want to hit these 2 points before I get to the finish tape. So think of them as checkpoints. And how I do this is because I have dynamic steering, which allows me to change the angle of my wheels at any point in time I want during the run. So I aim first at the first checkpoint, waypoint, and I go there. And then the second one, and then lastly the third one, the finish. So by doing this, by dynamically steering, I can correct for any offset I measure, and at the end, finish exactly at the tape, while going through both cans. So a little bit about the encoders. So I know I've talked about this, I've showed you the encoders, but how does it actually work? So the idea is actually very simple. We have 2 encoders connected to each of the 2 front wheels, and if you steer the wheels and start moving, you can see that the arc created by the rolling of the 2 wheels is kind of different. So for the top wheel, it actually moves a shorter distance than the bottom wheel, which moves a longer distance because it's on the outside of the arc, which is a larger radius. And by doing a little bit of math, which is just subtracting, we can figure out exactly where my EV is moving and what heading it's pointed towards.
So here's the EV up close. We have the motor back here. We have the driver, the battery pack inside here, and a custom-made shield with an OLED screen and encoder. The encoder and the OLED screen are used to adjust the parameters before the run. In the front here, I have the Ackerman steering system. And if we turn this servo motor, the steering spins with it. In the front here, we have 2 encoders connected to each free spinning wheel. And this is used to measure the rotation of each wheels to calculate how far the EV has gone, and then use a difference to figure out how much the EV has turned and what its exact XY position is. Now here is the important part. Getting everything to work together. It's not just about dynamic steering or dual encoders. They have to be perfectly synced to ensure that the car hits the right speed, meets the target time, turns accurately to hit those bonus cans, and stops exactly at the right spot. Alright, let's see how this works in action.
Thanks for watching. And if you're building your own EV, let me know what cool features you've added. Don't forget to like, comment, subscribe. See you next time.